Hi everyone, today we are talking about angle relationships with parallel lines. As a reminder, you do not need to write down everything that we'll cover in this video, but be sure to jot down important information and at least one example of each type of problem that we'll cover. Also remember that you can pause the video to jot down important notes, rewind to view information again, and fast forward if you think you got it. But be careful, make sure you don't fast forward too much that you end up missing out on something important. So we're going to start off by talking about parallel lines. Parallel lines are two or more lines, normally it's just two lines though, that never meet or intersect at any one point. So basically it means that they're tilted in the same direction. When we're talking about angles, we're talking about how they are tilted in the same angle. So they could go on forever without ever touching each other since they're going in the same direction. Speaking of slope, it means that they have the same slope. So if one has a slope of 2/3, the other also has a slope of 2/3, going up 2 and over to the right 3. So they just will never intersect, so they'll have no solution if you think about it that way. Those are parallel lines. Go ahead and jot down that definition and at least one of these example pictures if you haven't done so yet. Okay, so we know what a parallel line is. Now we're going to introduce a third line. It's called a transversal. So a transversal is any line that passes through those two parallel lines. So make sure that you add that. It's very important that you see the transversal is passing through two parallel lines. So in this picture, the red line is a transversal. I have two parallel lines, lines A and B, that are never going to meet, and then I have a transversal that cuts through. By cutting through, the transversal helps create 8 total angles. 1, 2, 3, 4, 5, 6, 7, and 8. Okay? 8 total angles. And it's going to create, in addition to that, 4 types of congruent angles. Remember that congruent means equal in measure. So there's going to be 4 types of angles that will be equal in measure. And we're going to talk more about what those 4 types of congruent angles are. But remember that congruent means equal in measure. So by cutting through the transversal with the parallel lines, we'll create 8 angles. 1, 2, 3, 4, 5, 6, 7, and 8. And so the next thing that we're going to go over is going to be the 4 types of congruent angles. So a lot of vocabulary to remember and stuff to draw. So if you want to, you should probably take out some color pencils or some kind of color for you to start labeling these angles. Okay, the first type of congruent angles that the transversal and parallel lines are going to create are called vertical angles. And vertical angles are always going to be congruent to each other. Vertical just means directly across from each other. So in this picture that you're going to want to put in your notes, angles 2 and 3 are directly across from each other. Since they're directly across from each other, we can conclude that they are equal in measure. They're congruent to each other. All this angle 3 has to do is just reflect, and then it's going to be the same as angle 2. Angle 1 and 4 are also congruent to each other. That's why they're the same color. 4 and 1, they're just reflections of each other. Or they could just rotate to get to one another. So a lot of this is just transformations. These angles are exactly the same. They are just, rigid transformations of each other. Similarly, 5 and 8, angles 5 and 8 are congruent. They're vertical angles, so all they need to do is just reflect or rotate to get there. Angles 6 and 7 are congruent because they're vertical, directly across from each other. So whenever you see an X made by 2 angles, you're going to see 2 pairs of congruent vertical angles. Because vertical just means directly across from each other. Okay, so that's your first type of congruent angles that are always created by a transversal cutting through 2 parallel lines. That's always going to be what they have in common. 2 parallel lines cut through by a transversal. The second type of angles that are congruent and created are going to be called your corresponding angles. A lot of times people get these confused with vertical angles, so be very careful. Corresponding means they're on the same side. So for example, one's on the left and the other one's also on the left. Okay? So in this picture, you'll see that the color coding is very important. You're going to need 4 different colors or 4 different ways to indicate that these are corresponding. Okay, so in this example, we have the pink, the blue, the kind of maroon color, and then the navy. So you'll see that the pinks are corresponding. They're both on the same side. The pinks are on the, I would say, like the top left side. So I would actually change this to top left and top left to be more specific. Okay. So these are both on the left side of the transversal. The transversal is in green, and they're both on the top. The like burgundy one is also on the left, but it's on the bottom left, if you notice that. So they have to be exactly on the same side. They're corresponding in every way. So I would even say on the same side and position. How about that? So the pinks are corresponding to each other. They're both on the top left. The burgundy ones are both corresponding to each other, bottom left. The blues are top right. The navy blues are bottom right. So each of those pairs are congruent. The pink ones, the pink angles, are congruent. They're equal in measure. If this was 135 degrees, the other pink would also be 135 degrees. Okay? So the color coding for corresponding angles is very important. They must be on the same side and same position. Top left and top left, bottom right and bottom right. Okay, the third type of congruent angles that transversals and parallel lines are making are called alternate interior angles. If you notice, the vocabulary word's getting a little more complicated each time. So we're talking about alternate and interior. Alternate means opposite sides. So you're alternating. For example, one's on the left, one's on the right. Interior, very important. We're talking about inside, but specifically inside the 2 parallel lines. So the 2 parallel lines here in dark green are going to make an inside space and outside spaces. This is the outside space here, and this is the outside space over here. So when we say alternate interior angles, there's only 2 pairs here. We have the burgundy one, and we have this black angle pair. These 2 burgundy ones, they're alternate because they're on opposite sides. One's on the left, one's on the right. However, they're both inside the 2 parallel lines. They're inside that space that's created between those 2 parallel lines. Similarly, the other angle pair, the black angles, they're also alternate. One's on the right and the other one's on the left, and they're on the inside. So interior angles are going to have 2 different pairs. Okay, and then lastly, we're going to have the opposite, alternate exterior angles. So we talked about the outside space, outside of the parallel lines. You have the pink and the blue. The pink alternate exterior angles are opposite sides. There's one pink on the left and one pink on the right. However, they're both outside the 2 parallel lines. One's on the left outside and the other one's on the right outside. For the blue, one's on the right outside and the other one's on the left outside. So there's 2 different pairs. So these 2 blue angles are actually congruent to each other. They're the same measurement. If this was, I don't know, 75 degrees, this other one would also be 75 degrees because it would rotate and then it would translate to meet up there. Same thing with the pink. It would rotate and translate down. So it would be the exact same angle. All of these are equal in measure even though they're in different locations because of rigid transformations. Similarly, for the alternate interior, the burgundy would just rotate or flip to the vertical angle position and then just translate down, and it would be the same exact measurement. So 4 different congruent angles. Very important that you remember those vocabulary words and you have it drawn and labeled nicely in your notebook, because if you haven't noticed by now, they're very similar to each other, so you can make a lot of silly mistakes. But very important relationships to remember as we examine our transversal and parallel lines. Last thing, I know there's so much that you have to remember, is that whenever you have angles that are not congruent to each other, like they're not equal to each other in terms of their measurement, they actually will make a straight line. So for example, this angle 56, this red angle and this blue angle clearly are not equal to each other, right? Like one's a small angle and one's a large angle. However, since the parallel lines and transversals will make something called a straight line when 2 angles are together, that means that they'll add up to 180 degrees. So I don't even need these measurements. I know that if 2 angles are not equal to each other on a transversal, that means they're going to automatically add up to 180 degrees, because by making a straight line together, they make 180 degrees. So that's a cool thing about your non-congruent angles. You have all these pairs of congruent angles that are exactly equal to each other, and then basically if they're not equal to each other, they're just going to always add up to 180 degrees. Like it's pretty straightforward. They're either equal or they add up to 180 degrees. Simple as that. So these 2 are not equal, they're going to add up to 180 degrees. You can even measure that. 56 degrees plus 124 degrees add up to 180. These 2 are not equal to each other, but they add up to 180. These 2 are not equal to each other, but they add up to 180. And these 2 are not equal to each other, but they add up to 180. Same thing with these 2, even though they're across from each other. They will also add up to 180, because it'll be like if this green one translated over to this space, and it would still together create a straight line. So straight lines always have angles that add up to 180 degrees. So that's kind of cool. So that's what we mean by this example right here. Even if they're not actually making a straight line together, you can always take one and translate it up and realize, oh, together they make a straight line, they're going to add up to 180 degrees. Okay, so make sure that this is in your notebook as well. Okay, and lastly, to remember, there is a shortcut involving Harry Potter if you can't remember all this information. So all you have to do is draw your 2 parallel lines in a transversal, mark any angle with a dot, and then find its vertical angle and mark it also with a dot, and copy that same pattern. So you're just marking any angle with a dot, putting a dot on its vertical angle, that's the one directly across from it, and then doing the same thing for the next one. Then you just connect your dots and you make like a Harry Potter scar, a little zigzag. And then the little trick to remember is if they both your angles have a dot, then they're equal to each other. Or if both your angles are blank and don't have a dot, then they also are equal to each other. If your angle, one has a dot and the other is blank, that means they're different, and then they're going to add up to equal 180 degrees. Okay, so that's just a little trick if you want like a cheat sheet. Okay, if they are identical, like both have a dot or both don't have a dot, they're going to be equal to each other. If one has a dot and one doesn't, we know they're different. They're going to have to equal to 180 when we add them together. All right, that's a ton of information. Double check that you have it in your notebook, and we're going to go through some examples. Okay, for this example, they want to know which angles are corresponding angles. You have parallel lines right here, and then your transversal. Go ahead and pause the video and try it on your own first. Okay, so which angles are corresponding angles? Corresponding, we said, needs to be in the same position and same location. So let's try angle VUS, this one here. Not drawing straight lines, but there you go. Angle VUS and WXZ. WXZ. Are they corresponding? No. One's like, if you kind of slant your head a little. One's on the left and one's on the right, so they're already no good. Okay, let's pick a different color so that we can label this better. Next one, angle VUS, okay, this one. And angle VUX, okay, VUX here. Okay, they look like they're both on the right-hand side, but one's on the top and one's on the bottom, so that doesn't work either. Okay, let's get another one going. Angle VUS, okay, they really like this one. And YXU, that's over here. Okay, this is more promising. They're both on the right-hand side, if we want to think about this as the right, and this is the left. Again, I'm slanting my head a little. And they're both on the top, so that one looks like it'll work. Let's try another one. Angle VUS, they really like this one. And TUX, angle tux, TUX, this one. Are they corresponding? No, one's on the right and one's on the left. One's on the top, one's on the bottom. They're not. These are just vertical angles, so that one doesn't work either. Looks like just angle VUS, this one right here, and YXU. Okay? So this one. Awesome. Let's try one more. Go ahead and pause the video and try this one on your own. Okay, so we have alternate exterior angles that they want. Okay, that was gross. Alternate exterior angles. Okay, remember alternate means opposite, and exterior means outside. Okay, so outside of our parallel lines. Our parallel lines are again slanted, but remember outside is here and here and opposite. Okay, so let's say this is our left, if we slant our head again, and then this is the right. All right, let's go through our options. Angle FEC compared to angle FEH. FEH, this one. Okay, one's outside and the other one's inside. Wrong. They need to both be outside. Let's try another one. Angle FEC and GHJ. GHJ. Oh, hey, they're both on the outside, and one's on the left, one's on the right. Okay, that one works. Let's try another one. Angle FEC. Again, they always have a favorite that they go back to. And angle IHE. IHE, this one. Are these two, well, one's inside and one's outside, so that's already no good. And they're on the same side, they're both on the right. So these are actually corresponding. So also no good. Wrong type. Let's try one last one. Angle FEC and angle IHJ. IHJ. Okay, this one right here. They are both outside, but they're not opposite. They're both on the right-hand side. So no good. So just FEC and GHJ. This one and this one. Opposite and both on the outside. Okay, so notice how important it is for you to just get everything straight, and then notice that you're going to have to tilt your head a little because they have their parallel lines drawn this way while we had it drawn this way. So you're going to have to like tilt your head a little, kind of rotate your head, and like this would be the left and this would be the right over here. Okay? Or you can tilt your head the other way and this is the left and this is the right. So that's the only bad thing about those kinds. Okay. Other type of problems you can work on Khan Academy are problems like this. It says below are two parallel lines, okay, with a third line intersecting them. We know that's called a transversal. What does x equal to? How many degrees is x equal to? Go ahead and pause the video and try it on your own. Okay, looks like these two angles, you should have seen that they're corresponding. Corresponding angles are equal to each other because it's just like a translation. You're just sliding it over. So x should be equal to 50 degrees as well. Okay, let's try one last one. Below are two parallel lines with a third line intersecting them. What is x equal to? So let's see if you can pause the video and try this one on your own first. I'm going to first see if these two are congruent to each other. Sometimes they're not, right? Let's see. They're both, well, let me go through the list. There's 4 types that can be equal to each other. There's vertical, there's corresponding, there's alternate interior, there's alternate exterior. Are they vertical? Are they directly across from each other? No. Are they corresponding? Same position, same side. They're same side, not same position. This is top left and this is bottom left. No. Are they alternate interior? Well, they're both exterior, so that one's already out. Both exterior, both on the outside, but they're both on the same side. It would have to be like this one and this one for it to be alternate exterior. They would both have to be on the outside, and one's on the left and one's on the right. So these two right here are not congruent to each other. They're not equal to each other. So this answer right here, I'm just going to put it in. It's not going to be correct. But these two are not equal to each other. Okay? So not all of them are equal to each other. You could have also used your Harry Potter method, put a dot anywhere, and fill in the vertical. Do the same thing on the other side, and then connect those to make your scar. And then you would see that this one has a dot, this one doesn't have a dot. So these two are not congruent, okay? But what we do know about non-congruent angles is that they're going to add up to equal 180 degrees. So we have 89 degrees for one of them, and we have x for the other one. So we know that that x is going to have to be whatever adds to 89 to get 180 degrees. So I'm going to subtract 89 on both sides. So x is going to equal to whatever 180 subtract 89 is. And that's 91 degrees. So that should be our answer. Okay, this should be 91 degrees. Because this angle, let me go ahead and put it in red here. This angle right here can be translated over, can be slid over to right here. So that together, that the 89 and the 91 are going to come together and make a straight line. A straight line is 180 degrees. Okay? So this one should be the correct answer. There you go. All right? A huge lesson on vocabulary and getting your left and right and top and bottom, in and out, and across, all that correct. But once you get it, you'll have 4 great angles that are automatically going to be equal to each other. And if not, they just add up to get to 180 degrees. So Refer back to your notes as you work on these exercises. Let me know if you have any questions, and I'll see you in class.